Welcome to the deep dive. Today we're tackling something pretty exciting.
Oh, yeah. What do we got?
It's the Qwen2.5-VL technical report. Comes from the Qwen team over at Alibaba Group.
Ah, Qwen. They've been putting out some interesting stuff. This is their latest vision language model, right?
Exactly.
Yeah.
The report's dated March 5th, 2025. Our mission really is to kind of cut through the dense technical stuff.
And get to the heart of it. Figure out what the big leaps are.
You got it. Understand the key advancements in this model.
Makes sense. We're diving into the tech, looking at what makes Qwen 2.5-VL tick and, why it's making waves.
Yeah.
And the context is important, too. The whole Qwen series, their open source philosophy. It feels like a real push to make this kind of advanced multimodal AI more available.
Definitely. And you know what really grabbed me right at the start?
What's that?
How they position it. They're actually comparing Qwen 2.5-VL to heavy hitters like GPT-4o and Claude 3.5 Sonnet.
Wow. Okay. That is bold.
Yeah.
Especially coming from an open source project, comparing itself to top-tier closed models.
Right. So that's the big question. What are the foundational advancements here? What gives them that confidence?
Okay, yeah, let's unpack that. So the core improvements are pretty wide-ranging. First off, significantly better visual recognition.
Just seeing things better.
Well, yes, but it's more about understanding precisely. Think about pinpointing objects not just generally, but with specific bounding boxes or even single points.
Okay, like precision targeting.
Exactly.
Yeah.
And then there's robust document parsing. It's not just reading text, it's analyzing invoices, forms, tables, charts, diagrams, even understanding the layout, extracting structured info.
That's huge for practical application.
For sure. And maybe the most surprising part, long video comprehension. We're talking hours of video.
Hours. Seriously.
Hours, and it can apparently locate specific events within those videos down to the second.
That's kind of mind-blowing. How does it even manage that amount of data, like processing different image sizes, video lengths? Doesn't that usually require normalization or resizing?
Well, that's where a key innovation comes in. They use a native dynamic resolution vision transformer, AVIT.
Okay.
It's trained from scratch using something called window attention. The dynamic resolution part is crucial. It means the model can handle images and videos of varying sizes directly.
Without squashing them into a standard format.
Exactly, so you don't lose those important details.
Yeah.
And window attention. Imagine focusing your eyes on just one part of a complex scene at a time, rather than trying to process everything perfectly at once.
Yeah.
It makes it much more computationally efficient.
So it's smarter about where it looks,
Yep.
essentially. More adaptable.
Precisely. It's like a highly adaptable visual processor that doesn't get bogged down by sheer volume or variety.
Right.
And the implications, well, it excels with static images and complex documents, like we said, but it also acts like an interactive visual agent.
An agent? How so?
It can reason based on what it sees, use tools, even perform tasks, think operating computer interfaces or mobile apps.
Yeah.
And the report stresses it does this without needing specific fine-tuning for every single task. It generalizes really well.
A visual problem saver that can also, like, use my phone. That's interesting. And didn't you mention different sizes?
Yes, good point. It comes in three sizes, 3 billion, 7 billion, and the big one, 72 billion parameters.
So it can run on different hardware.
Exactly. Catering to everything from, say, edge AI devices up to serious high-performance computing. The 72B model is the flagship, and that's the one they highlight for matching state-of-the-art performance, especially in complex document and diagram understanding.
Okay, got the big picture. Powerful visual understanding, adaptable, acts like an agent, comes in sizes. Now, the report mentions these four folds of technical contributions. What are those? What's under the hood making this work?
Right, the four folds. The first one is that window attention in the visual encoder we touched on.
The efficiency thing.
Yeah, basically optimizing how it processes visuals during inference, making it faster and less resource intensive. A smarter way to focus its visual crunching power.
Makes sense. Efficiency is always good. What's fold number 2?
Second is dynamic FPS sampling. FPS being frames per second for video.
Ah, right.
This basically extends that dynamic resolution idea into the time dimension for videos. It can intelligently handle videos recorded at different frame rates.
So it doesn't matter if it's choppy phone footage or smooth high-speed film.
Pretty much. Gets a more complete understanding regardless of the capture rate. It adapts.
Interesting. Okay. The third fold.
The third involves an upgraded MROP. That stands for Multimodal Rotary Position Embedding. It's specifically for the temporal domain understanding time in videos.
Okay.
And the key here is that it's aligned to absolute time. By linking its understanding of when things happen to a real-world clock, Essentially, it gets a much more sophisticated grasp of event sequences.
So it understands the pace of things and
Yep.
can pinpoint moments better.
Exactly that. The report actually has a Figure 1 that illustrates this time alignment idea. It's pretty near your understanding sequence and duration.
Makes sense. Tying it to real time seems crucial for deep video understanding. And the fourth contribution.
The fourth is maybe less a single technique and more a foundational element, the sheer scale and quality of their training data.
Ah, the data. Always critical.
Hugely. They massively scaled up their pre-training corpus from 1.2 trillion tokens to 4.1 trillion tokens.
0.1 trillion.
Yep. And they emphasize the quality aspect. You feed these models better, more diverse information, you generally get better results. This big jump in data is likely a major driver behind the performance gains.
Right, like giving it a much richer education. Okay, four folds. Window attention for efficiency, dynamic FPS for video adaptability, MRO for temporal understanding, and massive high-quality data.
Got it. That's the core technical foundation.
So let's connect that foundation to the results. The report calls them sparkling characteristics. These are the actual capabilities, right? First up, powerful document parsing. You said it's more than just OCR.
Way more. They call it omni-document parsing. It means handling documents from anywhere, basically.
Yeah.
Multi-scene, multilingual.
Handwritten stuff too, tables, charts.
Yep. Handwritten notes, tables, charts, even really specialized things like chemical formulas or music sheets.
Music sheets. Seriously. Okay, that's impressive detail.
It really shows the breadth they aimed for.
Hmm.
And to manage all this complexity, they developed something called the Qwen2.5-VL HTML format.
A special format.
Yeah, it's a unified way to represent everything in the document. Not just the text, but the layout, bounding boxes for charts, illustrations, text blocks. Everything's positioned and typed.
So it understands the structure of the document, not just the words.
Precisely. It knows this is a heading, that's a table, this image relates to that paragraph. It gets the whole picture spatially and semantically.
Like understanding a recipe page, ingredients here, instructions there, picture over here.
Exactly like that.
Okay.
Next, sparkling characteristic. Precise object grounding. What's that about?
This is about the model's ability to accurately find, point to, and even count objects in an image.
Pointing, like literally indicating a specific spot. Yeah, using either absolute coordinates like pixel addresses or structured formats like JSON. This allows for much more advanced spatial reasoning.
And useful for interacting with other systems, I guess.
Definitely. They trained it on over 10,000 object categories and used special data sets for really tricky detection and precise pointing tasks.
10,000 categories.
Wow.
Wow. And using absolute coordinates sounds vital if you need, like, robot-level precision.
It really is.
Okay.
Okay, third one. Ultra-long video understanding and fine-grained video grounding. It sort of touched on the ultra-long bit.
Handling hours of video.
Right. But the fine-grained video grounding part takes it further. It uses that dynamic resolution idea temporally, meaning it can not only watch a long video, but precisely pull out specific event segments, down to the second.
So finding that exact 5-second clip in a 3-hour movie.
That's the goal. The dynamic FPS training and the time-aligned MROP are the keys here.
Very cool. Okay, and the last characteristic mentioned.
Enhanced agent functionality for computers and mobile devices.
So moving beyond just seeing to actually doing.
Exactly. Leveraging all that grounding, reasoning, and decision-making we talked about, it shows real potential as an agent to, operate your phone or PC.
How does that work?
Well, they collected data like screenshots paired with annotations identifying UI elements, buttons, menus, sliders, and they're working on unifying operations into a standard function call format. Crucially, this includes the reasoning behind the action.
So it doesn't just see the send button.
It understands clicking, it sends the message, and it decides to do that after it finishes typing, for example. It understands purpose and sequence.
Makes total sense. Okay, let's switch gears slightly to the fuel for this engine. The data and training. 4 trillion tokens is just vast. What exactly is in that data?
It's incredibly diverse. You've got your standard image captions, obviously, but also interleaved image text data.
What's that?
Like web pages or documents with images and text mixed together. And they put this through a really rigorous 4-stage scoring system.
Scoring it. For what?
For quality. Things like, is the text itself good? Does the image actually relate meaningfully to the text? Do they add information to each other? Is the information density balanced? They wanted really high-quality connections.
That sounds crucial. Avoids learning spurious correlations.
Absolutely. Then there's OCR data, visual knowledge data, academic questions that mix modes, Localization data for spatial stuff, document parsing data, video descriptions, video localization data.
So data specifically for finding things in videos.
Right, and even data from agent interactions watching how tasks are performed. A big focus was getting precise coordinate information for grounding.
Wow. That four-stage scoring sounds particularly important for making sure it learns real visual text connections.
Definitely high effort, high reward. Now, the training process itself had three main phases.
Okay.
First, just training the vision transformer, the visual part. Second, multimodal training, where everything vision and language cards learns together, all parameters unfrozen.
Fine-tuning the whole system.
Kind of, yeah. And third, long context training. This is where they push the sequence length. It could handle way up to 32,768 tokens.
32,000. That's huge. That must link directly to the long video understanding.
Almost certainly. And importantly, throughout training, they used dynamic sampling, feeding it images and videos at their native resolutions, not resizing.
Right. Preserving detail. So pre-training, then alignment.
Correct. After that initial training, they did post-training alignment. Two stages here. First, supervised fine-tuning, SFT. They use the ChatML format for this, teaching it to follow instructions in a conversational way.
Like teaching it to chat properly.
Pretty much. Second stage was direct preference optimization, or DPO.
DPO.
Yeah, you show the model pairs of responses to the same prompt, one good, one not so good. It learns to prefer generating outputs like the good examples, helps improve quality, safety, helpfulness.
Learning from feedback directly.
Exactly. And they used about 2 million high-quality instruction examples for this, roughly half text only, half multimodal.
And were they just as careful about the quality of this data?
Oh, yeah. A two-stage filtering pipeline. First, they used another specialized model, Qwen2.5-VL Instag, to categorize all the instruction data by domain.
Sorting it out first.
Right. Then, stage 2 was domain-specific filtering. This used automated rules to catch obvious low-quality stuff and reward models trained to score the quality of the rest.
Reward models, like judging the data.
Kinda, yeah.
Yeah.
Judging how good a response is for a given prompt in that specific domain. They even used rejection sampling, generating multiple answers for hard problems and picking the best one to boost reasoning.
That is seriously thorough. Really focusing on quality control at every stage.
It seems like it. Okay, so that's the training. Now, the payoff. How does it actually perform? The report is full of benchmark results.
Let's hear some highlights. How about those college-level problems? MMMU benchmark.
Right, MMMU. The big 72B model scored 70.2. And as you noted earlier, they point out this is comparable to the GPT-4o.
Which is a massive deal for an open model on such a tough benchmark. What about math-related tasks?
On Math Vista, which mixes math and vision, the 72B model hit 74.8. The report says this beat the previous open-source state-of-the-art. Strong math reasoning combined with vision.
Impressive. General visual question answering, like MMBench.
On MMBench EN, the 72B model got 88.6, again surpassing the previous best. It also performed well across a bunch of other VQA benchmarks, shows solid general visual understanding.
And the smaller models.
Also competitive, interestingly. The 7B and 3B models held their own on many of these VQA tasks.
So it's not just about throwing parameters at the problem. The core design is effective.
Seems that way. Now, what about pure text tasks? Did the focus on vision hurt its language skills?
Good question.
Apparently not. The 72B model also showed leading results on several text-only benchmarks, MMLU Pro, Math, GSM8K, Human Evil, IFEVil.
So it's genuinely multimodal, strong in both vision and language.
That's what the results suggest. It's versatile.
Crucial. Okay, let's circle back to those sparkling characteristics. Document understanding and OCR, how did it stack up there?
This seems to be a real standout area. New state-of-the-art scores on benchmarks like CCOCR and OmniDocBench, which focus on parsing document elements.
Tables, layout, etc.
Exactly. And really strong results on broader document understanding benchmarks, too, like OCR Bench, InfoVQA, SeedBench 2+. Significantly outperformed competitors mentioned in the report, like InternVL 2.5 and Gemini 1.5 Pro on some of these.
Wow. Okay, that sounds like a potential game changer for anyone drowning in documents.
Could be. How about spatial understanding? Object grounding.
Also strong. Leading performance reported on benchmarks for both box grounding, drawing boxes around objects, and point grounding, pinpointing specific spots. That's RefCoco plus RefCoco.
And counting things. Yep, good performance on open vocabulary detection and top accuracy on counting benchmarks like CountBench.
Locating, identifying, counting, very useful skills. And the big one, video.
Also impressive results reported, particularly on long-form video understanding benchmarks like LVBench and MLVU, where they explicitly state It outperformed GPT-4o.
Outperforming GPT-4o on long video. That's huge.
It is. And improved accuracy reported for timestamp referencing and temporal grounding, finding events in time. Got a notably high IMIU score on Charade STA, which is tough for temporal localization.
Suggests those alt-textual tricks for time, like MOE, really paid off. Finally, the agent capabilities, interacting with GUIs.
Exceptional progress claimed here, too. Big improvements shown on GUI grounding benchmarks like ScreenSpot Pro, significantly outperformed baselines in offline tests like Android Control.
And in more realistic tests.
Strong performance, also reported in online evaluations. Android World, Mobile MIDI WAV Plus World. This suggests real potential for it to function as an agent in actual digital environments, not just simulated ones.
Okay, let's try and wrap this up, bringing it all together, this deep dive into the Qwen2.5-VL report. Well, it really paints a picture of a major step forward, doesn't it?
Absolutely. It's not just incremental improvement. We're seeing significant advances across a really wide spectrum, detailed document parsing, super precise object finding, understanding hours of video, acting as an agent.
Yeah, covers a lot of ground.
And it seems driven by those core innovations, the dynamic resolution VIT, the temporal handling with MROP, window attention, all fueled by that massive, carefully curated dataset.
Right. And achieving performance that's hitting or even beating state-of-the-art in many areas, sometimes even matching or exceeding top closed source models. That's the really striking part.
It really is. It shows how fast multimodal AI is moving.
Yeah.
And it gives us, a clearer sense of what machines are becoming capable of, how they perceive and interact with visual information.
And for you listening to this, understanding these capabilities, well, it could spark all sorts of ideas, right? Improving document workflows, building smarter interactive systems. The applications seem vast.
Which leads to a pretty big final thought, doesn't it?
Go on.
Well, given these incredibly rapid advances, how might models like Qwen2.5-VL fundamentally change how we interact with information, both digital and physical, in the, pretty near future? What new possibilities open up? And maybe what new challenges arise as these powerful capabilities get out there more widely? Definitely something to chew on as we watch this space evolve.